If two tables have the same column name, then you need a dot expression to distinguish which column you're talking about. And when two tables have the same name, then you need an alias to distinguish which table is which. These both occur when you join a table with itself, which is commonly needed. You need it in order to write down a query that considers two rows at once. So, for example, if you wanted to consider two parent-child relationships at the same time, like Finn is the parent of Ace and Ace is the parent of Bella, then you'd need to join the parents table with itself. Two tables may share a column name. Dot expressions and aliases disambiguate column values. When writing a select statement, the table in the from clause is a comma-separated list of table names with optional aliases. We haven't seen those yet, but here's what it looks like. If you want to select all pairs of siblings, then you'd need to consider two parent-child relationships at once. Finn's the parent of Ace, Finn's the parent of Ginger, therefore Ginger and Ace are siblings. What does it look like? In from, you join parents with parents in order to be able to consider two rows of the parents table in one long row so that you can write a where condition about it. Since parents and parents is the same name, we give them different names just for this query. Parents as A gives an alias or alternate name for the parents table, and parents as B gives another alternate name, so that when we have two different parent columns and two different child columns, we can talk about which one's which. Here's the condition that joins these tables together. A.parent equals B.parent means that the row from the parents table matched with another row from the parents table is only interesting if they have the same parent. Finn is the parent of both Ace and Ginger. And what about A.child is less than B.child? Well, this is a nice way of making sure they're not equal. You don't want to say that Ace is a sibling of Ace, because Ace is Ace. So Ace is a sibling of Ginger because they're different, and Ace comes first. Here's where we're joining with aliases. The result of this query is to show that Bella and Charlie are siblings, Ace and Daisy, Ace and Ginger, and Daisy and Ginger. And let's quickly explore how it works. I'll start up SQL, enter column mode, select star from a join of parents as A and parents as B. Again, I'm getting a long list of rows. This says Ace is the parent of Bella and Ellie's the parent of Finn, a row that has two disconnected pieces of information. If I add a where clause that says A.parent equals B.parent, now I get only the rows where the parent values are the same. So Ace is the parent of Charlie and Ace is the parent of Charlie. This is not useful for my query, but at least it's close. It's talking about two rows that both have Ace as the parent, and some of these are answers to the query we care about, like Finn's the parent of Ace and Finn is the parent of Daisy. Now I have a choice. I could say, and A.child does not equal to B.child, at which point I get that Bella and Charlie are siblings and Charlie and Bella are siblings. But that's saying the same thing twice. So the reason that we saw less than rather than not equal to in the query is to remove duplicates. Now, when you have a pair of siblings, you always list the one that's earlier in alphabetical order first. That's all the columns of the table. If we're only interested in the child column, writing just child will give an error, ambiguous column name. And that's because there are two different child columns. And so we need to say which one we're talking about. A.child and B.child will give us Bella and Charlie, Ace and Daisy, Ace and Ginger, and Daisy and Ginger as the four pairs of siblings encoded in the parents table. Okay, why don't you try one? Which select statement evaluates to all grandparent-grandchild pairs? So for example, you should get Ellie Ginger and Finn Hank. So why don't you pause the video and read through the options, and then I'll tell you the answer in 3, 2, 1. In order to represent grandparent-grandchild relationships, you need to make sure that the child in one of the pairs is the parent in the other. So for Ellie, Finn, Ace, Ellie's the grandparent, Ace is the grandchild. Finn is both the child of Ellie and the parent of Ace. So we do need to join 2 rows of the parents table together. We can only refer to columns that exist in those tables. So this use of grandparent isn't going to work because there are only parent and child columns. So we're down to 2 and 3. Let's take a good look at 2. A.parent equals B.child means that A.parent and B.child would be the same dog. So they can't be the grandparent-grandchild pairs. Instead, where B.parent equals A.child means that A.parent is the parent of A.child, which is the parent of B.child. So 3 gives us what we want, and we can verify it with an example. From A, we take Ellie Finn. So Ellie would go here, Finn would go here. From B, we take Finn Ace. So Finn would be B.parent, and Ace would be B.child. And therefore we get Ellie Ace as one of the grandparent-grandchild pairs. It is possible to join more than 2 tables together. That will yield all combinations of a row from each table. Here's an example. If I already have the grandparents table, which I get by saying A.parent, B.child from a join of the 2 tables where B.parent equals A.child, and then I give those new columns names like granddog and grandpup. This joins just 2 tables. But if I want to select all grandparents with the same fur as their grandchildren, then on one long row, I need to know the fur of the granddog, the fur of the grandpup, and the fact that the granddog and the grandpup are together in a relationship. And this should find things like Ellie and Ginger have the same fur, the small dots is short fur, and one is the grandparent of the other. So in order to answer the question which tables need to be joined together, you need to ask yourself, what is the information that has to show up all on one row? Ellie's fur, Ginger's fur, and the fact that Ellie is the grandparent of Ginger. That means we need a row from the dog's table, another row from the dog's table, and a row from the grandparents' table. When you join those together, grandparents, dogs is C, dogs is D, you then want to specify that the only interesting rows are the ones where the grandpup and the granddog have the fur that we care about in the dog's table, and that the fur is the same. This is a great time for you to walk through the steps of how this query works on your own by loading up the parents' table and the dog's table, building the grandparents' table, and then performing this join without the where clause to see all the combinations. Then apply the where clause to see how you filter those combinations to just the rows that you care about. And what you'll see emerge is a table of just Ellie, the grandparent of Ginger, and Finn, the grandparent of Hank, who are the 2 grandparents that share the same fur as one of their grandpups.